Good morning. Anyone in here who came to my talk last year? Oh, that's good. That's really good. So for those of you who I've not yet had the chance to meet, my name's OJ. I'm from Australia. And for the last couple of years, I've been fortunate enough to work under Rapid7 on a contract basis, helping improve, stabilize, and add features to Meterpreter. So everyone in this room knows what Meterpreter is, yeah? Nods? No? Shut up. Who uses it regularly? Can I actually see hands? Yeah, that's not too bad. Who loves it? Who hates it? Just me. Awesome. Awesome. Okay, well, I'm glad you're here. You guys, there'll be things in here that you've probably seen before. I'm hoping there's some stuff in here that you haven't seen, and with a bit of luck, you'll come away with some new knowledge that's going to help you in your day-to-day jobs. Most people in here would be pen testers. Is that fair to say? Yep. Okay, cool. Now, before I start, despite the fact that my talk is called, the new shiny, I want to talk about a couple of things that have been in there for a little while that not many people seem to know about. Some of you probably have known about it, but I'm going to cover those really, really quickly because they're pretty handy and they've been in there for a little while already. So we'll go over those. Once we've done that, I'm going to do a really brief recap of some of the core bits and pieces that you need to know about how Meterpreter works and how it talks to Metasploit. So this, again, you may find some of this, you already know exactly what this stuff means, but I think it's good to go over it. Some of it has a little bit of overlap from last year's talk, but I won't be going into it in the same depth. The WinINET and WinHTTP stuff in particular is pretty key for those people who use like reverse HTTPS payloads pretty regularly, particularly with proxies and things like that. And then we'll have a quick run through of how a Meterpreter session actually comes into being. And then from there, we'll actually get into the new shiny. Is anyone here a subscriber to the GitHub notifications for the Metasploit framework? It's a bit of a fire hose, I have to admit. Yeah, got a few nods. If you're pretty keen on MSF and you use it pretty regularly, even though it is a rather noisy mailing list, I recommend signing up for it because you get notification of the new stuff as it comes in. And instead of having to come to a talk like this and listen to me babble on for a while. Okay, so and by the end, I'm going to give you a demo of some of these features too. I'm also more keen on people asking questions as we go. So rather than waiting to the end, I don't know whether that's allowed or not, but if you stick your hand up and want me to clarify something, then please do that. So the work that I do is very much standing on the shoulders of giants. I know that's a bit of a cliched term, but it's definitely true in this case. And I want to make it clear up front that there's a lot of people who work on this, not just me, and they're all fantastic people. So you guys probably haven't heard of this guy. He's rather important in the Metasploit world. H.C. Moore is a machine. He's a phenomenal guy. He works at 1,000,000 miles an hour, and it's an absolute privilege to be able to work alongside this guy. He's phenomenal. So big shout out to him for his support. Now, Brent hasn't been in Rapid7 as long as many other people. Who's heard of Brent Cook before? Yeah, almost no one. This dude is phenomenal. He's a contributor to the LibreSSL project, and this guy, is the quality of work that he does is just sublime. So I really want to shout out to him. He's been a huge support for me over the last year or so. So keep your eyes out for this guy because he's very, very good. Spencer, who I think he lives over in Ohio, he's responsible for Python Meterpreter. Who uses Python Meterpreter? Anyone? No one. Oh, one guy. Jeez, you guys need to use Python. It's fantastic. So if you're getting any sessions on POSIX machines, Python Meterpreter is a place to go. Shout out to Tim. I couldn't find a photo of him, so I just stole his GitHub thing. Tim has been pretty active on the Android side. So for those of you who are starting to get more involved in mobile assessments, will hopefully see the benefits of using the updated Android Meterpreter. And there's a bunch of others as well who I'd love to shout out, but here's just a few images of them. They're all really, really great people, and I want to sort of acknowledge their efforts as well. So while I'm sort of focusing on a lot of the stuff that I've done, it's important to know that there's a lot of other people who have contributed to this too. Okay, so the first of the old shiny I want to go through just quickly is something called the Extended API. So the goal of the Extended API was to cover a set of features that make it easier for you to do post-exploitation on Windows that kind of don't belong in the Standard API. And for those people who don't know what Standard API is, it's like the first blob of actually useful stuff that gets shoved down to a Meterpreter session when it's first established. So it is a Windows-specific thing. I can't really think of anything that I'd be able to put into POSIX or something that's non-Windows at this point, but that doesn't mean to say it'll stay that way down the track. But it's actually really, really useful. There's a couple of things in here I think that are particularly interesting, and the first is the ability to query Active Directory services. There are other things, obviously, that you could use from the command line if you chose to, but having it baked in, I think, is actually really beneficial. So for those who aren't familiar with Active Directory service interfaces, this is just something that lets you query AD. So you can pull out information about machines and users and groups and all that kind of stuff. You can do some really handy enumeration. I'm pretty sure there'll be a number of people in this room who at some point have queried Active Directory and looked at things like machine comments and found admin passwords in them, for example. Who's seen that? There you go, see? So out of the box, there's a couple of queries that will just do that for you. And so you run a single command and yeah, you realize how bad administrators can actually be. So this is the current set of ADSI-related queries as it currently stands in Meterpreter as of maybe a week or so ago. There was only 3 originally when I first implemented this, and that was the computer enumeration, the domain query, and the user enumeration. The other ones were added recently by someone called Stufus or something like that on GitHub. I don't know where they are. I was kind of hoping that they would be here. So shout out to that person, whoever they are. They added these extra bits and pieces, and they're really, really useful. So domain query is kind of the nuts and bolts of how this thing works. Querying Active Directory is a little bit messy. You know, you've got LDAP syntax baked in, and it's not very nice. But the goal of this is for you to be able to sort of execute arbitrary queries if you know enough about LDAP and you know enough about the schema and you're comfortable writing your own filters. So you can literally pass in, you start by passing in the domain name. So you've owned some box that's on a domain. You can pass that domain name in. Then you pass in an LDAP filter, so you might say, I want the user objects to, the object class to be a user or a computer. And then you can just give it a list of fields, so SAM account name, you know, that kind of stuff, distinguished name, and whatever it is that you've specified will be pulled out of Active Directory. And there's a bunch of other sort of rather boring parameters at the end. But all of the other queries that you can perform that's currently baked into Meterpreter all use this behind the scenes. So it's important to know how this works if you want to go and create your own. Pardon the redaction, but this is actually a query from a site that I was working on last week, and I don't think they would be very happy if I exposed any information at all about what we were playing with. But basically, this is how it works. So the red block at the top there is the domain name, and it's sort of scattered throughout the rest of the screenshot, which is why there's plenty of red. But as you can see, all I did here was say, just give me the users, and I want the SAM account name and the name, and I want to limit it to 10 results in total, and that's kind of how it comes out. So it is actually pretty simple to use. This is a fairly crass example. Obviously, this isn't going to give you much. If you were actually doing an assessment, you would do something else, but hopefully that sort of captures the crux of what this thing allows you to do. So one of the baked-in ones that the contributor threw in recently was this DC enumeration. I think most of us are probably used to dropping into a shell and using nltest or something to get a list of the domain controllers. And that's 1 or 2 extra steps. But now you can literally just use the extended API, type in this command, and bang. And it'll give you the full distinguished name, all that kind of stuff. Pretty good stuff. Okay, service enumeration. Again, there's a number of like post modules and other tools that are in Metasploit that kind of allow you to do this already. But behind the scenes, they often use Railgun. Anyone use Railgun? One guy, and he looks upset. For very, very good reason. Railgun's fantastic, and it's horrible at the same time. So the more we can move away from Railgun, I think the better. So this allows you to do fairly standard sort of service-related stuff. So you can get a full list of all of the services that are running on the machine and aren't running on the machine, whether they're interactive with the desktop, you can get process IDs, that kind of stuff. And then for a particular service, you can query it directly and get more information. So this is handy for doing things like seeing whether there's unquoted service paths or whatever. Pardon the rather abusive DACL string. I'm yet to implement something that actually parses that into something readable. If anyone feels like contributing that, that would be lovely. Save me from having to do it. Or if you're a machine and you can read that as is, then good on you. And then there's a service control which allows you to start, stop, pause, all that kind of stuff, which I admit I haven't used, but it's there. So on top of the Active Directory stuff, there's also a very sort of thin WMI layer as well. It is pretty lean at the moment, and we're working on more and more features for this over the coming months, particularly with things like process creation on different machines. It'd be nice to be able to do that straight out of Meterpreter. That's currently not there. At the moment, it allows you to just query information. So you can get process listings and the typical WMI style querying. It is a little bit buggy in certain scenarios because behind the scenes we have to initialize COM with certain security attributes. And if the process that you're currently running in already has COM set up with conflicting security attributes, then it gets a little bit upset. But we're working on fixing that too. So here's just another simple example. So you type WMI query, and you just give it a full string that says, this is what I want you to run. And then behind the scenes, there's a bunch of horrible C++ COM code that tries to figure out the best way of extracting the info that you need. And it pulls it out and throws it out on screen. But this has like a full object model behind the scenes. So if you actually want to script this up, that's fully supported as well, which I think is pretty handy. And the clipboard. Has anyone used the clipboard stuff? I know you have. Anyone else? Does anyone know that this existed before today? Nobody. Awesome. This is one of my favorite things. And it's pretty handy for trolling people as well. So the good thing about this is you'd be amazed at how much stuff goes across someone's clipboard, right? It's pretty nuts. I mean, me as a dev, I'm using virtual machines quite a lot. And if you have your VMware configured so that you're sharing clipboards across your VMs, if you own someone's VM and it's part of a host where they've actually got clipboard integration, then you get everything they're doing on the host as well as in the VM. And it's pretty cool. It doesn't just capture text, it'll capture files and it'll capture like screen grabs and pretty much anything they do. If it touches the clipboard, it gets captured. And that includes KeyPass creds. So if anyone uses KeyPass and they copy and paste out a KeyPass, yeah, and 1Password too, that kind of stuff. The good thing about this is this actually taps into the clipboard chain in Windows. So it's not polling, so there's no sort of race condition issues. It's literally when the clipboard contents change, Windows gives it to Meterpreter, which is great. I highly recommend using this. You'll be amazed at how many credentials you'll pull off people's clipboards. Right, Mimikatz 2. Any Kiwi users in the room? Yeah, more than I thought. Excellent. So Kiwi is like the first iteration of the Mimikatz 2 extension in Meterpreter. The Mimikatz extension that we had before is still in there. And the reason it's still in there is because older versions of Windows obviously have different behaviors in their API. And Mimikatz 2 relies on newer features that come in service packs or later operating systems. And so if you run Mimikatz 2 on like Windows XP, SP1, it won't behave the same way. So if you're on an old machine, use the Mimikatz extension. And if you're on a new machine, use the Kiwi extension. But part of the reason that I created this was to include the new features that Ben Delpy, big shout out to Ben Delpy, he is incredible. And his sort of lifelong siege against Kerberos has been pretty entertaining, I think, for the rest of us. But he's awesome, so I really, really like that guy. Was to take his work and make it accessible to the plebs like us, and to take away that whole, do I run wdigest or do I use live-SSP? I don't know. I just want all of them. So that's what creds all does. It just runs through every single package and dumps whatever creds out on screen. So that's pretty handy. So my workflow tends to be migrate to whatever process I need, use Kiwi, creds all, and bang, and I'm done. So recommended. And the two other ones that I use quite regularly are LSA dumping. LSA dump is also a post module in Metasploit, but again, that uses Railgun. This is actually baked in, and it's Ben Delpy's code, which I would trust more than Railgun-related code. And the Wi-Fi dumping. So when you're popping someone's laptop, run Wi-Fi dump, and you'll get all their creds straight out, which has been particularly useful, has it not? It has. Okay. So that's really all I wanted to cover. So those two extensions in particular, there's other ones in there that have been in there longer. But next time you're on a gig and you think they might be useful, have a play with them because they're really quite handy. Right, the reason that I want to go through some information about stages and that kind of stuff is because I still speak to quite a few people who use this stuff all the time and are still not quite sure about what the differences between each of these things are. And so pardon me if I'm telling you something that you already know, but I think it's important to be clear. So a stager is a small piece of code that first gets executed when you've gained control. So I'm not talking about an exploit here. The exploit does something that allows you to get control. But as soon as you've got control, that's what your stager is. And a stager is usually a very small piece of code that has a very small set of responsibilities. And the first one is to establish communication to Metasploit. So whether that's a reverse connection, so its job is to open a socket and connect back, or it's a bind session, and so it opens its own socket locally and listens and waits for an incoming connection. It's particularly dumb, and so once a connection's established, it will just wait for whatever it's given, and as soon as it's given it, it'll run it. That's basically all a stager does. There is a little bit more to it, and I've got that anything else question down the bottom. For those people who aren't in this room that came to my talk last year will probably know exactly what I'm getting at here. So the Metasploit stages do a little bit more when it comes to TCP-related communications, because the last thing we want to do when a Meterpreter session is established is create yet another socket once we've actually got Meterpreter running. That seems a bit useless. So what we do in the stager is once we've got the communications and we've pulled down a copy of Meterpreter and it's running, we actually pass that socket over so that we can reuse the existing channel. So that's what the stager is. This should be pretty familiar to you guys, right? They're all the different stager types. Okay, the stage is the second thing that goes down. So once communication is established, Metasploit will send a payload down. In the case of this talk, and I think most of the time people will be using Meterpreter as the second stage, or so I should say the first stage. And that gets sent down the wire, and it has to be in a particular format so that when it executes, everything kind of wires up appropriately, and we'll go into that a little bit more. So when I say hot patched, what I mean is a copy of something called metserv, which is the sort of core of Meterpreter. It's the first thing that gets sent down, takes over communications, wraps it up in an SSL channel, and then pulls down more information, more extensions. That metserv binary actually has to be patched in memory prior to being sent down the wire. And I'll go over the details of that, in just a minute. Sometimes there is an intermediate stage. So for the most part, Meterpreters will just have one stager, one stage, and then you have your session. In the case of POSIX, for example, there's actually an intermediate stage. So it's like a smaller payload than the full-blown Meterpreter. And that's sort of designed to kick out a bit more space and make room and then pull the next sort of piece down. But I think, to my memory, I think there's only one, and POSIX is the only one that I can think of. Any questions so far? We're all good? Awesome. Okay, so the example stage is Meterpreter, VNC inject, shell, things like download and execute. And there's a bunch of other ones, but they're effectively the stages. So you're probably used to typing in, set your payload to platform, whack, stage, whack, stager. So that's kind of the format, right? So Windows/Meterpreter/reverse TCP, saying platform, we're saying we want the Meterpreter stage, and we want our stager to be reverse TCP. Okay? So, handlers. This is actually pretty simple, but I just wanted to be clear. So this is the thing that lives on the Metasploit side and handles the session-related stuff that the Metasploit needs to do in order to keep Meterpreter running properly. It will connect outbound in the case of bind payloads, but for the most part, I think everyone in here is using reverse, right? Nobody sort of manages to own an org remotely using a bind payload. No? It probably wouldn't surprise me if that was true anyway. But for the most part, we set it up so that we're listening for inbound connections. At the moment, we have an interesting problem with it because every handler that you launch, you specify an architecture and a machine, and you're specifying payloads, which means it's kind of tied specifically to one use case. Whereas ultimately, what we'd really like to have is a handler that is kind of agnostic. And when a connection comes in, it just knows, oh, this is a 64-bit Meterpreter session, so we do this. Or this is HTTPS, so we need to do this. And so that's what we're kind of striving for. We're making steps at the moment, we'll go through these very shortly, moving towards supporting a universal handler. So you don't have to have 1,000 handlers, you can literally just have one, and it will hopefully be smart enough to know what to do when a connection comes in. So it's not yet universal, but hopefully soon it will be. Are there any devs in the room? Any Win32 devs? Not that you'll admit? Yeah. So there are two APIs in Windows that allow you to do HTTP and HTTPS communications, and they're almost exactly the same. The function names look the same, the parameters are kind of the same, but there's some fundamental differences that make things a little bit painful for us. So what we're used to doing when we type reverse HTTP or reverse HTTPS, behind the scenes, we're using something called WinINET, which is kind of the user-level API for dealing with HTTPS comms. And behind the scenes, that adopts all the settings that come out of the user's Internet Explorer. So all the internet options, that all sort of gets adopted magically. But there are a few limitations with this API that make it difficult for us to do more advanced stuff like things like cert verification on a SSL endpoint, that kind of stuff. It makes it pretty hard. And not just it being hard, but in order to do it in a stager, the amount of shellcode you have to write to actually get that working is sort of, it's over the top and makes it very infeasible. So we've been living with WinINET for quite a while, and now what we're doing is we're moving towards using something called WinHTTP, which is another API that's designed to sort of work at a service level. That's got more features, and it makes it a bit easier for us to do the advanced stuff. But the problem we have there is that WinHTTP doesn't automatically use the user's Internet Explorer settings. So if they have a proxy configured, if they have NTLM or something like that, it just doesn't know about it. So you have to have extra code that says, whoever the hell I'm running as, go and find out their IE settings and then wire that into the API so that it will actually function. So the changes that we've made around this recently, when I say recently, like in the last sort of 3 to 6 months, a number of people have had all kinds of issues trying to understand why they were getting, say, an initial connect back, the stage would get sent down to the target, and then from there nothing would happen. Has anyone seen that recently? No? I have, and it's pretty painful. The reason for that is because we've got two different APIs in place. You use reverse HTTPS as your stager, that uses WinINET, and then Meterpreter goes ahead and runs WinHTTP. So because of those differences and because of things like proxy settings and various other auth settings, you can get in a scenario where one will work and one will not. But now we have new stages. The other stages are called reverse WinHTTP and reverse WinHTTPS. And these two stages are exactly the same really as the reverse HTTP stages. The difference is that it's using WinHTTP API behind the scenes. We're trying to get some consistency, and I would say long term, you'll probably find that the former will disappear and WinHTTP will sort of reign supreme, and that will happen probably without your knowledge. Hopefully, it will remain out of your knowledge because that means it worked without anybody having any issues. But yeah, we'll see how well that goes. So that's important to know, particularly when you're in interesting environments that have proxies with incorrect versions of HTTP and yeah, there's some interesting edge cases. But what we're aiming to do here is we're getting to a point where we can actually have Meterpreter validate that the server, the MSF server that it's connected to, is actually the one that it's supposed to be talking to. Because at the moment, pretty much everyone who's doing their assessments is kind of blissfully unaware of the fact that their sessions can be hijacked. And I think it's our responsibility as security people to make it so that when we shell some person's box, that shell will only talk to us rather than somebody else. So that's important, and that's something that clients have been asking for. So we're sort of taking steps towards that now. So anyway, this is a visual representation of how I felt when I started working with these two APIs. And so I probably shouldn't have shown you this now that I'm asking for contributions. But yeah, it really is horrible. It's really horrible. So I will love you eternally if you're happy to get involved. And this is one of my favorite gifts. I had to shoehorn it in here somewhere. So that's what it feels like. Anyway, moving on. So I'm going to quickly go through the session establishment thing. Apologies to those who I know have heard this before. I went into this in quite a bit of detail last year, but I'm not going to do that again. So the Meterpreter session is established in the following way. So you run an exploit. Because remember, Meterpreter, stages, sessions are all post-exploitation. The exploit runs, and that's when we kick in. So you'll have something like an exploit run, or you'll generate a binary, or you'll have a PowerShell payload, or a VBA, or something, and that gets run. And when that gets launched, the stager that's embedded in that payload is what runs. So the stager will then establish the communication with your MSF listener, or the MSF listener will connect to you, depending on the payload you've chosen. And from there, depending on the configuration, it will generate a stage. It may or may not be hot patched, but in the case of Meterpreter, it generally is. And then from there, it sends the stage down the wire, and the stage will download it. It will allocate some memory, read write X, copy it in, jump to the first byte and say, go. And then behind the scenes, a bunch of other magic stuff happens. So things like reflective DLL injection, again, which we mentioned last year. And then from there, Meterpreter takes over communications, and it sort of gets a little bit smarter, downloads a bunch of extensions, and you end up with your session. Okay? I think I mentioned, here we go, that's right. So in the case of TCP, what happens in the stager, like I said, is that you end up with a socket that you've used to actually talk to MSF, and you want to reuse that in Meterpreter. And so there's a little standard behind the scenes for the stages. It takes a socket handle and it writes it into the EDI register for those assembly fans. And then when the code for the second stage gets executed, it assumes that the socket handle is in that register and will pass that into a DLL main call when Meterpreter actually starts running. Although that's changed a little bit now. Inside that stage, there is a reflective loader stub. For those not familiar with that, reflective DLL injection is a way of loading DLLs directly from memory rather than going to disk. And it does a bunch of funky stuff that avoids registering the DLL with the host process, so you can't actually see it in things like Process Explorer, which is super handy for those of us who are trying to be a little more forensically silent. So that's actually sent down with Meterpreter as well. So when it's invoked, it gets the socket handle, and off it goes. And from there, you actually have a session. Is that clear? Yeah? Good. Right. So again, this is another, I don't know who created this GIF, but I love it. I love it. This was in my slides last year too, and if I come back next year, it's going to be in there again. But it's gold. It is gold. Okay, so in the case of Windows, once Meterpreter is running, so MetServe is the first piece that goes down, as I said. It downloads the standard API. Hello? That'll teach me, won't it? You can't stop watching it, can you? It's like, do it again, do it again. I'll just stop talking and watch this for the rest of it. Okay, so standard API has all the things like process management, file system management, registry handling, all the core bits and pieces that we can use as building blocks to do more interesting stuff. So when MetServe is finally running, Metasploit framework will send a copy of standard API down, and it reflectively injects itself and wires in all the commands, and so you end up with more commands appearing in your help. On Windows, you also get something called priv. And priv has a bunch of like privilege-related stuff. So things like get privs, get system, all that kind of stuff. Who thinks get system is an exploit? Good. It was a bit of a giveaway in the question, wasn't it? Yeah, it's not an exploit. Get system is literally what it says on the tin. It gets a system token, but you have to have privileges already to do it. It won't do any exploits for you. Just thought I'd throw that in. So when standard API and priv are loaded, on the Metasploit side, all of the commands that are supported in those extensions are wired in, and you can actually start using them. So finally, we have a Meterpreter session. That's basically what happens. All we have to do is kind of type something in, hit go, and bang, all this magic goes on behind the scenes. But there's plenty of pretty amazing stuff that goes on. Right, so that's a recap. So hopefully we're all on the same page. And then from here, all the new stuff that I'm talking about that sits on top of that will hopefully be a little bit more clear. Right, so one of the needs that we found is that clients want to be able to track how successful their exploitation attempts have been. So you might have a phishing campaign, and you know that you've sent some dodgy document to someone. You want to know how much it's been opened. So you want to know whether someone forwarded it to somebody else. So what we do now is we bake something into the payload called a UUID. And the UUID is just I think it's 16 bytes, and it contains like a unique identifier. It contains platform information and a timestamp for when that was generated. And so every single time that payload is fired, that UUID is passed to Metasploit. And so on the attacker side, we can now go, oh, okay, we know exactly where that payload came from. So you're starting to be able to get some statistics around how well your payloads have been functioning, which is pretty useful in some scenarios. I personally don't use it, but I know that other people do. So we do want to be able to track them, and later on we want to be able to do more interesting things with them, like, okay, if I can look at the UUID, then I know that that's a 64-bit thing, so I'm not going to send you a 32-bit binary, because obviously that would be bad. So this, again, is sort of moving towards the notion of universal handlers. So we'll get to a point where the first thing that happens when a session is established is that the target will send the UUID down straight away, and we'll be able to know exactly how to handle that. That's ultimately the goal. And to be able to say, we've just got a shell from someone that we don't know about, and ignore those. Be honest, who would turn down a shell? Nobody. Your honesty is fantastic. I probably wouldn't either. But it is actually an important thing to be able to do. We certainly don't want our shells talking to other people, and we technically shouldn't be talking to other people's shells either. Yeah. Okay. So UUIDs are randomly generated. When I say random, what I mean is elements of the UUID are randomized, but certain things remain static. So if you have a reverse HTTP and you know it's bound to a 32-bit Windows machine, then that information is still baked into the UUID. But there are other things that aren't. But you can control it to a point. There are some parameters, these payload UUID raw and payload UUID seed. You can configure those. And the reason why they're in play really is just to give you fine-grained control, and then you can do some kind of pattern matching on the UUIDs that are generated to be able to categorize them better or something similar. But for the most part, I would be surprised if they got used to a great extent. Out of the box, UUIDs are now baked into the URIs that HTTP-related Meterpreter sessions are using. I'm guessing HTTPS is probably the most frequent transport people are using. Is that fair to say? Yeah? A few nods? Has anyone picked up on the differences in the URI strings at all? Because there used to be like a 5-character thing, like init M or something, and now it's this kind of huge, conspicuous-looking thing. No one's picked up on that? So inside that big, long string is the UUID and a bunch of other sort of random stuff to try and make it look like it's not doing anything too sinister. But next time you're having a look at a Meterpreter session on the wire, you'll notice that the UUIDs are actually baked into the URIs. Sorry for all the acronyms, but if I expanded the acronym every time I spoke, we'd be here all day. Okay, so behind the scenes, we don't yet straight away send the UUID down to MSF, but MSF asks for it as soon as the session is established so that it can actually do its thing. And there's also something called the machine identifier, and this is just a little helper thing that allows you to say, I've got multiple sessions on the same box, even if I'm not running on the same user or whatever. So it's like a little hardware-style fingerprint for the machine, and that should be consistent across Python, PHP, all of the implementations of Meterpreter. From my testing, that's been true, but remains to be seen whether it's effective on every single case. Looks like I duplicated something there. You can actually track UUIDs as well. So think about, like I said, using the phishing analogy, you might have a campaign and you want to bake the idea of a campaign into the payloads. You can actually do that using this payload UUID name. And behind the scenes, what Metasploit does is it actually takes the information of that UUID and the URI that is associated with it and throws it into a little sort of JSON-style database on the file system. And that means later on in your handler, if you turn on tracking, or you turn on what we're calling paranoid mode, if a session comes in that has a UUID you have not registered, it will ignore the connection. It'll terminate the session. And it is actually useful. So that's one of the features that HD implemented. And you'll find, if you do that, you'll find this payloads.json in your .msf4 folder, and that contains all of the registered payloads that you've generated. And you can also see the info in sessions-v inside MSF console itself. So that kind of gives you a pretty expanded view rather than the table list view. You'll be able to see the UUID, the machine ID, the last time the session checked in, which is pretty handy. So if you're unsure as to whether a shell comes across as dead, if you go sessions-v, you'll see it's been like 300, 400 seconds or something since the last check-in from the session. I think we'll probably end up making that a little more visible because it's quite handy information to have. So yeah, as I said, that gives you whitelisting. And to do that in the handler, to actually enable this in the handler, you set this ignore unknown payloads to true. And if you get a session where either the URI or the UUID don't match, then it will ignore it or terminate it. So they have to both be valid. Okay. Everyone clear so far? No questions? Lovely. Right, so as I said, we have a whole new set of stages. There's the WinHTTPS ones, which I've already covered. Now there's a bunch that have this sort of underscore UUID on the end. And this is us moving towards what I was talking about before, where the first thing that happens is we send the UUID down. So other than that, they're exactly the same. It's just a little bit more shellcode that says we've got the UUID baked into the stager, and that goes down first. So that means that we can actually get to the point where we're not even sending the stage down before we validate that the session is one that we would expect to see. Okay? There's not too much rocket science behind that, which is why I probably won't cover more. But if you have any questions about that, then hit me up at the end. Some other work that's been going on inside the stages in particular is around resiliency. So up until now, what we've kind of done is we've had this simple retry loop around the connection. So if we fail to connect to the MSF listener, we try again. But if we successfully connect and we're slowly downloading our first stage, if that terminates, then we're kind of lost. We lose our exploitation. So now we've got more stuff going on in the stages that's actually able to detect when the communication is cut halfway, or whether we end up with half a stage rather than a full stage, and then we'll actually retry it from scratch in that scenario. So with a bit of luck, when you end up with like high latency environments or you've got really crappy networks, you will still hopefully get a session out of it in the end. And there's a bit more of this to come on the HTTP side. We haven't quite finalized that yet, but we're working through it at the moment. So keep your eyes on GitHub, because that will happen hopefully within the next couple of months. Okay, so as I said, when we generate a stage that we send down to the stager, we hot patch, basically shove some shellcode into a certain part of the PE. And so what it used to do, you know about the PE file format, just basics. There's a bunch of headers. There's an old DOS header that basically doesn't get used. And so we use that to save on a little bit of space. And so what happens is that area which was the DOS header gets filled in with a bit of code that effectively does the following. It figures out where it is in memory. It figures out where the reflective DLL loader function is and calls it. And then when it's loaded, what's returned from that function call is a pointer to DLL main. So we now kind of have a valid DLL sitting in memory, and we can call DLL main with parameters on it, right? And then from there, we take the socket handle out of EDI, shove it on the stack, make the call, and Meterpreter takes over. And then when that finishes, it also does something called exit func handling. So when you set up your payloads, you've probably seen exit func, and most of the time, don't worry about it. What that's doing is saying, when I finish my Meterpreter session, how should I tear myself down? So if you've done an SCH exploit to get your shell, you should choose SCH as your exit func type, because that will make sure that it's cleaning itself up properly when it finishes. Same with things like exit func thread and exit func process. You try and choose the one that's the most appropriate for the kind of exploit or binary or whatever it is that you've gone with. And so that was part of that little hot patching. Whereas now we don't do that anymore. What we do with this new little hot loader thing called the Meterpreter loader, inconspicuously named, it no longer does some of what was done before and does a little bit extra of its own. So we've changed the way that we pass in metadata to Meterpreter instances because we want to be able to do some more advanced stuff. We're going to get into that in just a minute. But what we need to be able to do is generate what we're calling a configuration block, and that lives in memory alongside the stage. So instead of giving Meterpreter a socket handle reference so that it can take over communications, Meterpreter now expects a pointer to somewhere in memory where that configuration block lives. And so this new loader doesn't take the socket out of RDI, shove it on the stack and make a call. It takes it out of RDI, writes it to an area of memory inside the config block, and then sends a pointer to the config block to Meterpreter instead. And it no longer worries about exit func. It lets Meterpreter handle that for you. And I'm not going to show you the assembly code. I did that last year, mixed reviews. Some people love assembly, but most people don't. So I won't show you that. Right. Old school Meterpreter, you kind of had one configuration. You were able to say, I want you to use this transport type and I want you to connect to this port, and we're done. And that's great, and it's worked really well for a long period of time, but it's no longer enough. Particularly when you're working against organizations that actually do have a blue team and they can pick up on sessions and they're able to block IPs and ports and do all this other stuff. What you want to be able to do on the fly and up front is to be able to say, if this doesn't work, try over here, or hit this IP, or hit this port, or use TCP here and use HTTPS over there. And so this configuration block that we've developed is just something that allows you to define that up front. Okay, so that is, when I say it's hard-coded into the binary, that's probably not the best use of words. What it's actually doing is we take a copy of metserv off disk, hot patch it. We're about to send that down the wire. We generate a config block and we stick it immediately after. And then when we're hot patching, we kind of give it a hint to know how far ahead of metserv itself is where the config block starts. So that when it ends up in memory on the target, it can do just some basic offset calculations and figure out where that pointer to the configuration is before it goes ahead and executes. Okay? Yeah, so back in the day, we didn't really have the ability to do all these kind of complex things, and so the implementation of this was designed to solve that problem. At the moment, even though the configuration block supports the idea of multiple transports, so go to this endpoint on this type of transport or go to this endpoint on this type of transport, it's not currently enabled from the command line. So if you use MSF Venom to generate your payloads, you can still only specify one. So that'll be like reverse TCP, lhost equals whatever, blah, blah, blah. So we're currently trying to come up with a way of exposing that on the command line, but it's not easy to do. It's not easy to do. Unfortunately, it gets pretty messy pretty quickly, but we'll probably end up with something soon, and I'll await your feedback/hate when that happens. It's haters everywhere. Okay, so now the config contains a bunch of stuff. The first part of the configuration contains what we're calling session data, and as you can see, it has the first thing in it is the socket handle. So that's the thing we used to just pass in. Now it's actually written to memory. That socket handle is always 32 bits. Even on a 64-bit session, it's a 32-bit, because I don't think anyone in this room has experienced a case where Windows has allocated a socket higher than the 32-bit. So we kind of felt like there was no point in worrying about the 64-bit scenario, because every socket handle I've ever seen has been low enough. So if it crashes arbitrarily, just submit a bug on GitHub or something. That contains the identifier for the exit function. So Meterpreter looks at that when it's finished, and it does the appropriate function calls to terminate the session without hopefully crashing the host that it's living in. It has a session expiry time. Who knew that there was actually a session expiry in Meterpreter? Yeah, I didn't really know about it either. But basically what that is up front you're saying, regardless of what happens, at this time, stop functioning. So if you lose a shell and it's still running somewhere after however many seconds that you've configured it for, it will actually shut itself down, which is a good thing, right? But we didn't kind of make use of it. So that feature, the metadata for the expiry, which by default is 1 week. So if you're working on a long-term gig, one of the first things you should do, if you're using default settings, is to change the session expiry. Because you'll be sitting there one day using it and it'll just say Meterpreter session's died, and you'll hate me because you'll think it's a bug, but it's not. It's your session actually terminating when it should. And it also contains that 16-byte UUID that we were talking about before. So that's all in the first part of the configuration. Immediately after that, there is the transport info, which I said at the moment we only support one thanks to the command line, but the functionality is in there that will support many. And so inside that, there's this sort of custom URL style format. If you're dealing with HTTP comms, it'll look like a standard URL. It'll be HTTP or HTTPS : whack IP address, port number, whack, followed by the URIs that we were talking about that have the UUIDs in them. In case of TCP, it's TCP : whack. And what we're doing there is kind of just baking in this functionality that allows Meterpreter to look at that URL, parse it, and choose the appropriate transport depending on what it is that you've configured. Now, there's 3 timeouts that go with every single transport session, and they are comms expiry, retry total time, and retry rate. Now, comms expiry kind of doesn't really make a lot of sense in the TCP world, because the notion there is, when was the last time we received a packet that, not really a packet, sorry. When was the last time we received a Meterpreter packet? Not just a normal TCP packet, but a Meterpreter packet that contains a function call and some TLVs that say, oh, I want you to go ahead and do this railgun call, or I want you to run creds, or whatever. So some kind of message that's come from Metasploit. That's what the comms expiry is. And so in the case of, say, HTTP and HTTPS, that kind of makes a little bit more sense, because we're constantly polling behind the scenes to say, have you got something for us? And if Metasploit responds with nothing after a period of time, it'll go, well, I'm going to assume that something's failed, and I'll either roll over to the next transport or I'll terminate my session. So that's what the comms expiry is. The retry total and retry wait are kind of tied together. So when communications fail, or your initial communications are kicking off behind the scenes, what it's doing is attempting to connect, and then when it fails, it will try again. And it will try again every retry wait seconds. So if your retry wait time is 10, then it means every 10 seconds it will try to connect again. And it will continue to do that until the total time has been reached. So if it's 60 seconds for the total time and 10 seconds for the wait time, every 10 seconds it'll poll, and after 6 attempts, it will stop. Okay, so that's what those timeouts are. And we'll cover those off again very shortly when we do examples later. There's a couple of things that are specific to HTTP and HTTPS comms, so user agents, the kind of stuff that you do want to have some control over, and the SSL certificate hash, which we use for validation with paranoid mode, which we'll be talking about shortly. And then immediately after that, extensions. So that could be any extensions like standard API, priv, etc. And we do support this from the command line, which I'll explain shortly. But basically all that is a bunch of 32-bit values that say how big the extension is, followed by the bytes that make up the extension. Same again until we get to a value that's 0 size, and we assume that we've reached the end of the extension list. So that gives us the ability to generate a big configuration that has multiple transports up front, and all the extensions that we want hot-wired in as well. Saves us having to send them later. And this is particularly useful with Stageless Meterpreter, which will be coming up, I think, very shortly. Transport data URLs. I've kind of covered this for the most part, so I might skip over. But what I wanted to show you is the kind of URLs that you'll see inside the configuration. So it supports IPv6, things like, supports that as well. You can see here what I'm saying. This is where the horribly long URIs are thrown in. So have a look at those. There's some interesting stuff going on there. Oh, and the one little quirk that's worth noting is that bind TCP. So we just pretend that if you haven't given us a host, that you actually intended to bind rather than connect to something. So here's my programmer art that shows you what it looks like. That first part, that blue bit, is the metserv DLL as it currently stands, with a tiny bit of patched shellcode in the DOS header right up front, immediately followed by the session, the transport information. As you can see, there should be multiple, and this is an attempt at the sort of additive part for the HTTP comms, and then one or more extensions followed by what's effectively a null terminator to indicate the end of the configuration. So you can generate this stuff yourself, and it's heavily documented on the wiki. And if you decide to read it and find any gaps, then please let me know. Make sense? Nobody's asleep, although some people have left. Right. Stageless, I think for me, personally, the changes that have been made over the last however many months, Stageless is one of my favorites. And so the notion of a Stageless Meterpreter is effectively taking the stager and the stage and the configuration and all this other stuff and throwing it into one big binary up front. This has changed my world because I'm from Australia and our internet sucks. So if you shell someone remotely and you end up with, like, if you modify GPO and say, just shell everyone as they log in, which is fantastic, you end up with that sort of million galloping horse problem because everyone logs in at the same time of the day and your VM just gets smashed with 1,000 connections and it's trying to upload Metserv, it's trying to upload standard API, it's trying to upload priv once for every single one of those connections that comes in. So you hit an org even with 5,000 users, it will just completely decimate your Metasploit instance. So that's bad. So it was bad for me. So I wanted to solve that problem, so it was great that other people had that problem too, so that I could go ahead and solve it for everybody and not just me. We're at a point actually which is quite interesting because back in the day, we would get in a lot through exploits. And to be honest, we don't really do that much anymore, do we? Who's got in recently, literally got a foothold on a network with a binary exploit? Yeah, almost. I've not done it, I've not had to. There's so many other ways in that are really, really trivial. So the idea of having an exploit where the size is actually a problem isn't so much of a concern anymore. It still is a concern, but not so much of a concern. What we're more interested in is being able to establish sessions in a reliable manner. We're interested in getting everything up there and running as quick as possible and have that working in high latency environments as well. And so that's what Stageless is all about. We also have the problem of like some AV products, some IDSs are actually getting pretty good at detecting when the stage is being sent. So SEP in particular, I've noticed over the last few gigs that I've worked on, even if you're doing HTTP, so technically it's encrypted, that first stage gets caught. And SEP says, no, we're not doing that. Which is great for them, and it's good to see things improving, but it sucks for us because we still want sessions. So I've found Stageless has been fantastic for this because I'll generate a binary that has everything in it up front. And so when you establish your session, it's already got Metserv, it's already got standard API, it's already got priv. Literally all it does is connect and say, this is who I am, and that's it. Now that's really great. Think about that from the high latency perspective. If you shove that up on a web server or on a file share inside an organization and you shell everyone from the file share, they all literally have shells instantly and there's no uploading of any information. So you can, even from Australia, shell 10,000 people and every session connects without any problems, which is fabulous. And so I use Stageless Meterpreter a lot in my work. Highly recommended. So as I said, it takes the configuration block that we just talked about and bakes everything into that, generates a binary that has everything in it. So it's like the typical stage followed by the configuration inside the executable itself. By default, you will only get Metserv. Okay, so if you generate, I'll show you how this is generated in just a minute, but by default, when you create a Stageless Meterpreter, it will only have Metserv in it, and that's the thing that's responsible for communications, right? That's the thing that wraps things in a TLS socket so that things aren't as easy to detect. But you can add more. You can add whatever extensions you like. By default, I usually use standard API and priv because that's what has to be there for things to function anyway. And you can specify all of these things on the command line. If you think about it, when you have a Meterpreter session fully established and connectivity drops, if it tries to connect back to you again, that's effectively a new stageless session, to draw a bit of an analogy. Does that make sense? So it's already got all the extensions that it needs. It might already be doing some other processing as well. But because it's functional, it's got everything that it needs to function, MSF doesn't need to give it anything. We just need a new level of communication established. So the difference between a reconnecting stage and a stageless Meterpreter instance are actually exactly the same, which is really nice because on the MSF side, once we cater for one, we kind of get the rest for free. The only slight pain at the moment is if you had something like incognito extension wired in and you lose your connectivity and it reconnects, MSF thinks that that's a new session. So behind the scenes, it still actually has incognito wired in. When you type use incognito, what it does is it queries Meterpreter to say, do you actually have this extension loaded? Because if you do, just tell me which functions are exposed and I'll wire them in locally. So you still have to type use incognito, but it doesn't actually send a copy of the binary up because it knows that it's already there. I'm hoping to get to a point where we don't even have to type use. Up front, it'll just know. But that's not quite there just yet. I don't know whether this is readable up the back. I tried to squeeze way too much. If not, just come and have a look on my machine if you want to have a look. But basically what I'm trying to show here is the nasty command line that you can use to generate stageless payloads. The main difference that I want you to focus on is this one character here. So usually you'd have a slash here, right? Because that says I want Meterpreter as my stage and I want reverse TCP as my stager. What we hear is saying is that I want Meterpreter and reverse TCP to be my stage, which is where the name stageless kind of comes from. And so in that first example, we're just doing a standard stageless, and that doesn't contain anything other than metserv and the config block. The second example, the bit that's important is this bit here. So we're saying I want standard API and priv to be baked in, and you can add as many of those extensions as you like. So extapi, kiwi, Mimikatz, the works, and it'll just keep appending them. And they'll get loaded as soon as your stageless binary gets run. And so that last example was pretty much the same as the previous one, but as you can see, I've just chucked a couple of others to show you that you can add them on yourself. And obviously, if you have your own extensions, it will work with that as well. Right. So as I said, the big wins for me, it doesn't have to be downloaded. So you can literally deploy it on someone's network, and it's like instant shells every time it runs without any heavy communications, which is great. AV and IDS tend to ignore it. You will have a problem with the binaries themselves being caught by AV because, let's face it, they've got signatures that are quite well known. Even the extensions do as well, but I'm sure a bunch of you use things like Veil and a bunch of other bits and pieces that will allow you to encode those. And stageless works encoded, no problems at all. So once it's actually running, it'll work flawlessly for you. Network comms is the biggie, like I said, in high latency environments, so where you have crappy internet like we do. Network traffic is basically non-existent for a new session to get established. Mass shelling doesn't result in huge uploads, thankfully. That's a godsend. Excuse me. And as I said, it actually, out of the box, supports the idea of session establishment after reconnects because the code is basically exactly the same. Now the config, which we've already gone through, so I'll probably skip over this. But what's interesting about this is that you can actually change a lot of this stuff on the fly once your session has been established. So all the timeouts that are transport specific, your session timeout, obviously the extensions, because you're used to loading extensions already, all of these things can actually be changed on the fly now, which is super handy. So that sort of leads into these transport changes. Is anyone familiar with the transport changes that have gone in, or have our workflows kind of stayed the same? Probably assume the latter for the most part. Well, hopefully after seeing this, you'll start playing with this stuff because it's really, really super handy. So as I said, the original Meterpreters, you kind of have one transport and that's it. And it stays that way. You can't really change it on the fly. And you have to specify that up front when you're using MSF Venom, and you kind of really can't change that after the fact. We also had the problem where if there was any network connectivity problems, for TCP, you would lose your session. Right? Whether someone, I don't know, just puts their laptop to sleep or, some data center goes down or whatever it happens to be. If you're using TCP comms, you're screwed, or you were screwed. HTTP was different because, well, it's a stateless nature of HTTP. It's constantly polling. So if it fails to connect once, it doesn't matter. It'll just try and connect again later on. But TCP didn't do that. But now, that's not the case. So we've done a bunch of work around these transports, and that allows you to, on the fly, add transports. And this is actually surprisingly helpful for when you're tag teaming people across the planet. So Dan and I work together quite a lot at the moment. And we're in this world now where I can say, hey, I'll just hand this shell over to you, and I can add a transport that points to Dan's listener and just hit go. And the session will stop talking to me and start talking to him. And he'll do his thing, and then he'll just run transport next, which you'll see again, and it'll bounce back to me. So behind the scenes, it's actually keeping track of multiple transports, and you can just send your session all over the place, which is super handy, particularly if one of your IP addresses gets blacklisted and communication stops working, it'll just move over to the next one and reestablish connectivity. So for those of us who sort of have something like a cloud-based attack platform, you can have 4 or 5 boxes, one of which is your main attack box, use the other 4, set up some IP tables rules that literally just forward ports, and have transports for every single one of them. And unless they block all 5 of your IP addresses, you will still have a session because it'll just keep going to the next one that works, which is awesome. Well, I think it's awesome. Okay, now this transport list is actually like a circular linked list behind the scenes. So you can add a new transport, you can remove old transports, and the way that it works is if a connectivity fails, it will just go to the next one. And all of those timeouts that we were talking about before, they apply to each and every one of those transports. So you can choose to say, if I can't connect via TCP in 60 seconds, then go to the next one. But in the case of HTTPS, I want to try for an hour. So each one of those you can configure as well, and you can change them on the fly. And so it will continually cycle through all of those transports until it's able to connect, or if the session expires. So if your week-long session, if it gets to a point where it's failed to connect on any transport, the Meterpreter session will terminate itself. As I said, I really want to change this soon because a lot of people really love to bake multiple transports in up front, but we're still not there. But hopefully we'll get that sorted out as well. But this, the transport types are exactly the same as the one you're used to using. So you can do bind, you can do reverse TCP, reverse HTTPS, all that kind of stuff. I'm going over old ground, so I'm just going to move on. When we implemented the transport, we had this kind of nice little side effect that you could then implement the idea of sleeping. So it's kind of nice to be able to say to your Meterpreter session, just shut up for the next hour because I'm being watched. But we didn't have that before. So after doing these transport changes, it was pretty simple to go from that to sleeping is just the same as switching transports to myself with a timeout. So that's how it's implemented. When you type sleep and give it a number of seconds you want it to sleep for, it'll terminate comms, it'll wait for that timeout to expire, and then it'll just carry on doing the transport stuff that it did before, which is great because let's say that the blue team managed to catch you just as you were sending it to sleep. That transport that you try and connect back on might no longer work, but it'll just go to the next one. So you get all of that stuff for free as well. Sleep is cool. And it will work for a very long time. So this morning I had to put another couple of sessions to sleep that came back from last month. It's like, oh, I forgot about you. Just go back to sleep again. But don't forget to change your session expiry, right? Because if you put a shell to sleep for a month and you haven't changed your session expiry, when the timeout kicks in, it goes, right, session's dead. I'm just going to terminate. And that makes me sad. So remember to change your session expiry times. But the good thing about sleeping is that Meterpreter itself doesn't stop running. So the main dispatch loop for comms has stopped, and it's just sitting there waiting for that timeout to expire before it actually does anything. But if you've got any async operations going, like keylogging, or clipboard monitoring, or packet sniffing, or any of that, they all still run. So you can kick those off, tell it to go to sleep for an hour, and then when it calls you back in an hour, you can say, right, dump all the data, and all the data it's captured over that period of time will get sent down to your session. That's pretty handy. Right. As I said, when a new connection comes in, even if it's from an existing session, we don't yet have the ability on the Metasploit side to be able to say, we've seen you before, we know who you are. So that's one of the limitations that we have at the moment is that anything related to do with sleeping or transports is currently deemed to be a new session. But hopefully we should have something in place that will make that go away in a short period of time. One thing to note is we have staged handlers and we have stageless handlers now. So the stageless handler knows that when it gets a connection, not to send the stage down like it does when you are using staged payloads. Okay, hope that makes sense. What we don't want to do is have a stageless Meterpreter run and for Metasploit to still blindly go, here's the binary, because at that point, you've lost all the benefits of not having to download stuff, but also AV is seeing what's going across the wire and might kill your session. So it's important to have a stageless listener for stageless connections, otherwise you are missing out. If you do that, it will still work. That first chunk of information that's downloaded by Meterpreter stageless sessions will just be ignored, and it'll carry on as if nothing had ever happened. But as I said, you really don't want that to happen. So ultimately, you should make sure that you have a stageless listener. As we go towards universal handlers, I've got to stop doing that, sorry. That will go away. You won't have to care. Right. What did I mention here? Oh, yeah, this is quite cool. Pro tip. If you're using a staged Meterpreter session, right, you create your binary using MSFenum or an exploit or whatever it happens to be, and you fire it off and it goes away and it eventually gets executed and calls you back. The configuration that was baked into your initial stage does not have to be the same as the configuration that's put in that configuration block. Now this is really, really handy because what you can do is you can tell your staged listener to connect to you on one port, but the configuration of the stage points at a different port, okay? And what that gives you is the ability to say, when you connect back, when a transport fails, connect to the stageless listener rather than the staged listener that you originally connected on, okay? So to do that, you can use the reverse listener bind port functionality to say, I want you to tell it to come in on this port, but actually listen on this port. So that means you can actually have two handlers and you can handle both the cases of staged and stageless without having to suffer the pain of doing those uploads unnecessarily. How am I doing for time? Sorry, just before. No pressure. Oh, okay. Whoops. All right, I'm going to go through this really quickly because I want to show you some demo stuff. Hopefully they won't hate me too much. So paranoid mode kind of wraps up some of the concepts we've been talking about before. We want to be able to say, is this the handler that I should be talking to? What I might do is sort of briefly go over this. But all we're going through here is saying we don't like being man in the middle. We don't want our sessions hijacked. We don't want bad guys exploiting the fact that we've exploited somebody, because that's not cool. And paranoid mode is about wiring all of those payload UUID tracking things in and doing things like SSL hash verification. So our payloads, our stages are all now capable of being able to say, when I run and I talk to an endpoint, I'm going to look at the SSL certificate hash that comes off the comms, and if it's not what I expect, I'm just going to terminate, right? And that's actually important in cases where, you know, the client, like you might be hitting a bank or someone else that's particularly sensitive, and they're saying to you, how do you make sure that nobody else is using your sessions? You can say, well, we use this thing called paranoid mode, and we validate that only our listener is the thing that it's happy to talk to. And that works with staged and stageless. And it's got this nice little side effect of avoiding being man in the middle by things like AV, which I'm sure everyone's seen, right? Even if it's HTTPS, it still gets man in the middle. So you can put something in your payload to say, yeah, don't talk to me if AV is man in the middling, and that avoids you getting caught. I'm just going to ignore this because there's just too much based on the amount of time that I already don't have. So sorry about that. Come and talk to me about this afterwards if you're really interested in it. But I really want to show you some of this stuff very, very quickly. Righto, so now is that big enough, or shall I? Can you guys see that clearly? All right, so I just want to show you this. This is just a quick resource script that's setting up a single staged listener. Okay, this shouldn't really be news to anybody. So I'm going to fire that off. Oops. Okay. Ignore the fact that I don't have Postgres running. I'm not going to do any searching or anything anyway. Okay, so we've got one listener running there. So now I'll go to my dodgy Windows VM and we'll kick off. I've got a bunch of payloads here that I use for testing. These are all just out-of-the-box MSFenum generated payloads. Okay. So we've got a session. This is what sessions-v looks like. So as I was saying, there's that check-in, so you know that it was actually active quite recently. Here's the UUID that says this is an x86 payload on Windows, and this is the identifier for the machine. So if you get multiple sessions on the machine, you'll find that this machine ID is exactly the same. And again, you can do some kind of tracking and whatnot behind it. Okay, so now. So I'm terminating MSF. Back in the day, if you did this to a TCP session, it would end. And people are still doing that, assuming that it's ending when it's not. So if I do this again, I just want to show you the reconnection stuff. There we go. So there it is, and it is the same session. Note that despite the fact that that was effectively stageless when it connected the second time, it ignored the sending stage. So I don't know if you can still see sending stage just up there. So it sent the payload down, but Meterpreter ignored it. But we've got exactly the same as we had before. So it is exactly the same session, which is cool. Okay, I'm going to skip some of the more boring bits, but this time I'm going to kill that off and start with a different resource script that has quite a few more listeners, because I want to demonstrate sort of the difference between staged and stageless. Okay, so we've got 4 listeners there. The staged version, stageless version, staged, stageless. And the giveaway there is the lack of the slash. You're using underscores instead. Am I about to get booted? No? Right, so what did I want to demonstrate here? I can't read it either. Wait for session, no. Oh, I was supposed to show you the no sending stage thing. That was pretty stupid. Sorry, just give me 1 sec. I'm going to fire that off again when that's running. Okay, so let's do this, and this time I've got the stageless listeners. So what should happen here is that the existing session, which is effectively now staged, is connecting back on a stageless listener. And if it's not too fast, there we go. Sending stage again. Did I open the wrong one? Probably did. Yeah, I did. Okay, right, so what I'm going to do now is quickly show you the transport stuff. Let's go back. You know about -1? Sessions-i -1? -1 gives you the last session that's currently functional. So instead of having to figure out the ID of the one you want to talk to, if you know it's the last one, just use -1. So that's pretty handy. So if you type transport list, you should get a full list of all the current transports that are wired into your Meterpreter session, and the one with a little star at the front is the one that's currently active. And so what I'm going to do quickly is just add, I still got my stageless, yeah I do. So this is what the syntax is like. So you type transport add, and you can give it localhost, or lhost effectively, the port, and the type. So there I'm just saying I want reverse HTTPS. And so if I list transports at this point, you can see that particularly pleasant URI that I was talking about before, with the port and everything baked in. And as you can see, these timeouts are all individual, so we can change those depending on the transport that we're using. So let's say that we know for some reason TCP comms are currently being monitored, and we want to change. So you can say transport next, and what that does is, as you can see, it's a bit messy, but you say changing to the next transport, and it says session's closed, but before that got outputted, this one came in. And you can see that it's picked up on the fact that it's either an orphaned payload, which means it's kind of something that's been running and trying to connect back and has just achieved that, or it's stageless, which is exactly the same thing. So again, let's use that -1 thing. And we know it's the same because behind the scenes, it still has the transports that we had before. And you can see that the current one now is the one with the nasty URI. Okay, and so this will happen magically behind the scenes when there's network connectivity problems. Okay? That clear? We're all good? And so there are two commands. Like I said, there's a circular list, and so we don't yet have the ability to say jump to this particular transport, but you can say go to the next one or go to the previous one. So if I went transport prev, that would do exactly the same thing and hopefully reconnect. Whew. Note the lack, see how it didn't say sending stage? So this is actually the stageless listener that it's connecting to. And so it didn't actually send a stage down. So a lot less noisy. There you go. Okay. All right, let me just quickly skip over some of this other stuff, and I'll probably just get to the thing that I really wanted to show you. I'm happy to give you guys like a personal demo if you want to see more of this stuff, but because I'm very low on time, I can't really show any more. So this one has a stack of different listeners. So this is they're 32-bit, they're 64-bit, HTTP, HTTPS, blah, blah, blah. There's a few different ones in there. So what I wanted to show you was this. Okay, you see there's a bunch of don't do this from Australia. Okay, so I think there's going to be 120 sessions. I'm kind of nervous. When I'm actually, I'm kind of nervous. As you can see, it's like, all right. Now, it takes a little bit of time behind the scenes to wire these in. So you'll see, slowly but surely, it's recognizing. So if I keep running it, we're up to 59. See, it just takes a little bit of time. So for each one of these sessions behind the scenes, it's querying to make sure that they're functional. And one of the things that's been changed recently is to try and determine whether a session's dead. So rather than you sitting there going like, get UID, it's this info, and it's going unknown, 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 it'll actually tell you whether the session's dead. Nearly there. Come on. All right, 120 sessions. I'm sure you guys have had way more sessions than this. So what I'm going to do, actually I should make this a bit bigger so you can see what I'm about to do. I'm about to, can you guys see that? I'm about to kill Ruby. So I've had so many times where MSF has crashed because it's out of memory. And when you've got a number of sessions like this, it's like, no, I've completely lost my foothold, unless you had some kind of HTTP. So what I'm hoping for, and this did work, is when you fire it up again, every single one of these sessions should reconnect. All right, they're already started. And they should all be effectively orphaned or stageless sessions in the case of HTTP. And these are the TCP ones. See, there's no sending stage. 120. All right, it's not going to be populated just yet, okay? But it's going to be starting. Come on, here we go. So the very first time I was on a gig, after this stuff had been implemented, and I had all kinds of crazy stuff going on with my console, and I know I needed to restart Metasploit, I kind of had that moment where I'm thinking, really hope I didn't mess this up. And I did. So, and so they didn't all come back, but some of them did. But as you can see, slowly but surely, what's happening is each one of those sessions is being identified, and hopefully all 120 will work. All right, so that's 64-bit, that's HTTP, HTTPS, TCP, the works. It works on POSIX. Spencer's implemented it for Python, so you get these transport resiliency features in Python. PHP hasn't been touched yet. I would love someone to do PHP. Who loves PHP? Yeah, you're not going to admit it, are you? I'll be like, I'm going to come speak to you in a minute, mate. But yeah, that's basically it. Now, the one last thing I want to show you. I promise it's the last thing. Okay, let's go to this. And I'm going to use the extended API. And I'm going to start the Clipboard monitor. Okay? And then I'm going to say go to sleep for 30 seconds. So back over here, I could say, all right, I'm just going to copy that. I'm going to choose a couple of these files, copy that. I'm going to go snip and Just take a screenshot and copy that. So we should have some stuff on the clipboard now. Maybe I shouldn't have done 30 seconds. I should have done maybe 20. And then hopefully very soon. Here we go. All right, so our session's back. I should learn to type. And so if I go, remember as I said, I have to go use, because even though it's wired in, Metasploit doesn't know about it, but it's instant. And then I should be able to go clipboard monitor dump. You can see the text that we captured. It's downloading the files that we'll copy onto the clipboard. And it's pulled down the image that we'd actually captured as well. And that all happens despite the fact that Meterpreter has gone to sleep. Use this. It's really, really handy. Now ignore the fact that I'm gleaning over slides. I'm going to jump to here. All right. I just want to finish off by saying, yes, I am very biased. I think Meterpreter is awesome. It should be in your toolkit. It shouldn't be the only tool in your toolkit. But it is an awesome tool. And I think over time, with more contributions from some pretty amazing people, it will be more so. I would love more people to be actively involved in it. I know that's a tall order. But if you do have anything at all, even if it's just comments or pain, or just open up a GitHub issue and let us know what the pain points are. Big shout out, like I said, to the guys at the start, particularly the open source contributors, because they're giving their own time. Everyone's sort of lacking in time, but those people seriously are awesome, and Carl is awesome too. Are there any questions?